a lot of difficulties here. Sorry. So Chebyshev's inequality, last thing that you'll be expected to learn in this section, seems sort of like it comes out of left field, but it's just an important thing to learn about. So I'm just going to define it and show you how to use it. It's not really anything that doesn't seem to connect directly to this discussion, except that it does somehow hinge on the idea of standard deviation and variance. Okay, so suppose we have a probability distribution that has a given mean mu and a given standard deviation sigma. Then the probability that a certain random outcome will fall between the values mean minus some number c and mean plus some number c is at least 1 minus sigma squared over c squared, where again, c is the some positive number. Okay, so doesn't really seem very useful, but here's the idea. I'll draw a picture before I show you how to solve this particular problem. So you have a distribution and you don't really know anything about how it's shaped. So it can have some crazy shape, but you can find the mean and then you can look at mean minus some number and mean plus some number. So that gives you the area here that I am shading. So what the Chebyshev's inequality says is that for a probability distribution, the probability that an outcome will fall between these two values, which is to say a random outcome will fall within the shaded region, the probability of it falling there is 1 minus sigma squared over c squared. So the likelihood that you'll find a value or that you'll select a value at random that falls within this area is given by this number, at least this probability. So that's another important thing. It says at least. It could be bigger than this probability. This is just a lower bound. So it cannot be any smaller than this probability. So for this problem, this example, we're given a mean of 5, we're given a standard deviation of 1, and we're asked to estimate the probability that an outcome will lie between the values 3 and 7. Okay, so first off, we need to find out what the value c is in order to use Chebyshev's inequality. We can see that 3 is 2 away from 5, and so is 7. So that we can say 5 minus 3 is 2, and 7 minus 5 is 2. So that implies c is equal to 2. Once we know c, we're good to go. So the probability that we're looking for, which one way to denote the probability is to say the probability that our value, how do I want to say this the right way? Yeah, let's do it this way. The probability that our value, our random value x, lies between mu minus c and mu plus c is given by 1 minus sigma squared over c squared. So really I should put in the values here. So that's 5 minus 2 and 5 plus 2, which is 3 and 7. So the probability that some random value lies between 3 and 7 is given by 1 minus the standard deviation squared, or the variance there, 1 squared over c squared, which is 2 squared. So that's 1 minus 1/4. And so that gives us 3/4. So Chebyshev's inequality says that for this particular setup with a mean of 5 and a standard deviation of 1, the likelihood of that a random variable will fall between 3 and 7 is at least 75% or 3/4. It could be greater, but it's at least 75%. Okay, so that concludes section 7.5 And that's where we're going to stop talking about probability and statistics. So we'll be moving on to a new topic in the next lecture. So keep your thinking caps on and get ready for new stuff. But this finishes out probability and statistics. All right, y'all.